am Anjan and welcome to the 12th video tutorial of the Verilog course series. In this video, you will be getting to know how 8:1 multiplexer works and how to design a Verilog code for it. For a better understanding, I split the video into three parts, that is pre-coding part, coding part and the post-coding part. Now let's move on to the pre-coding part. In the pre-coding part, you will be knowing the functionality of the 8:1 multiplexer, and now coming to the functionality, it will take 8 inputs as an input in the inputs, and it will drive all of them to a single output using 3 selection line inputs like this. If you see in this truth table, you can get it. It is the combination of S2, S1, S0. These are the selection lines, and if it is 0, 0, 0, you will be getting D0 as an output. D0 means here I0. Whether it can be 0 or 1, the value within the D0 will be coming as an output. And remember that it is not 0, 0, 0. It is 0, 0, 0 combined 3-bit number. It is not a single bit, 3 single bit individual numbers. Okay. Now for any values like 1, 1, 0, it will be D6. It is in the order, like the combined value of 0, 0, 0 is 0 and 0, 0, 1 is 1 and 0, 1, 0 is 2, and it is go on like this. 1, 1, 1, 1 is 7. I given the values like this, and now let's move to the coding part. In the coding part, I declared here as underscore 821 multiplex mux as an my module name. I here introduced underscore before the module name because the first value of the module name should not be any numeric like 8 or 3. It should be any character like letters, small case letters or big case letters, or any underscore, but not the numeric value. So I introduced underscore before the module name. And here are my port list. Here S0 to S2 are input ports, 1-bit input ports. I0 to I4 are 1-bit input ports, I7, and Y is the single output port, which I declared here as registered because in the coming minutes I will be showing that it will be introduced in the always block, that is procedural block. Any output which is introduced in the procedural block should be written in the form of register. I will show. Here it is. Always I introduce here Y, so it should be written in the form of register. Here it is. Here I concatenated S2, S1, S0 so that I will be getting a 3-bit number like 0, 0, 0. Here 3-bit. I already told here itself that it will be no single individual 1-bit number. It will be a combined 3-bit number given to the 8:1 multiplexer. For 0, 0, 0 condition, I take an I0, and these are the case statement flow, and here I ended the case, and here I ended the end module. Now let's move on to the post coding part, that is on the tool. Here I written the whole code, that is just similar to what you seen in the presentation, and here I pre-simulated it, but I didn't take any values for you. I will be taking now. I will be taking selection line as 0, 0, 0, 0. So that I will be getting an output I0. So that I should give the I0 value something like 1, let's say. Let's simulate it for 10 nanoseconds. Here I got it, Y equal to 1. You can also check for another values like 1, 0, 0. So that I will getting I4. 1 means S2. S2 should be 1. One 0, 0, and S1 S0 should be 0, 0. Okay. So that I will be getting I4. Here I will change it to 0. Let's run for 10 nanoseconds. Here I got it, y equal to 0. Let's now move on to the schematic part. Here it is. It is showing the multiplexer RTL Mux. It is designed by the tool itself. Here you can see the input ports and here is the output ports, and the selection line which is given to the multiplexer is like single line, single variable with 3-bit size, which is coming from these three. We can also take like a 3-bit number and given to the this multiplexer, but in the traditional way we will be using 3 selection lines. That's why I taken 3 selection lines and drive all of them to a single input. Okay, if you like the video, do like it and share it to your friends, and subscribe to YouTube channel, and also don't forget to see on the description box for more Verilog questions, Verilog related questions. Thank you.